Good day, everyone. Welcome back to my YouTube channel. I am Dr. K. Today, we shall be discussing the structure of glucose. In this video, I will be explaining how to draw the structure of glucose. We'll talk about the beta 1,4 glycosidic linkage in maltose. We'll discuss the structure of maltose also. I'll be talking about glycosidic linkage. Please, I want you to stay tuned and follow as I take you through the process. So, when you're talking of glucose is an aldose. It's one of the aldoses. So when you're talking of other aldoses, we have the glycerideide, we have the erythrose, we have the ribose, and we have glucose. So those are the four that make up the aldoses. And how do you identify the aldoses? They have their carbonic group at the end. They have something like this. They are similar to the halides. So that's the aldoses. So we also have the ketoses, but the ketoses have their own carbonic group second to the last end. Are you getting it? So let me make it clearer. Let me make it clearer. How do you know which one is an aldose? So this is how you know. The carbonic group will be at the end, 0. Then you have something like this. So that's the carbon at the end. Now, if this is an aldose. But for a ketose, the carbonic group will be at the second carbon to the end. Now look at here. So second carbon to the end. So this one is an aldose. So the one that has is a carbonic group at the end, that's an aldose. So this is a ketose. Now, so let's proceed. Now the formula of glucose is C6H12O6. This is the formula. C6H12O6, the formula of glucose. Now, to draw the structure, I'll be taking you the process of drawing the open chain structure of glucose, the closed chain structure, and the cyclic structure of glucose. Now, please follow me through. So now, if you want to draw the structure of glucose, what you need, this is the general formula, C6H12O6. Now, if you have to draw it, then you need 6 carbon. That's 1. Let me make it clearer. 1, 2, 3, 4, 5. Then you have 6. So that's that. And after drawing, you have your hydrogen here. Okay, sorry. This is how it will be. You need 6. 1, 2, 3, 4, 5, 6. Now, your carbonic group will be here, 0, and you have your H here. Then you have hydroxy group. You have 5 hydroxy group there. OH, OH here, OH here. So you have OH here also. So the same thing, your hydrogen here. Your hydrogen here. You have hydrogen here. You have hydrogen here. Another one here. Then you have another one here. So this structure I just draw, this is the open chain structure of glucose. Open chain structure of glucose. This is the open chain structure of glucose. Now, to draw the open chain structure, to draw the closed chain structure, how do you do that? This is the closed chain structure. Now follow me. Let me take you through the process. This is an open chain. Now I want to draw the closed chain. So this is the closed chain structure. Follow me. You draw like this. This H here followed by CO. H here, then CO. Now this is the first carbon. You start from here. Then for the C, then you have your H, you have your OH. Same here. Now look at it. C again. C again. 1, 2, 3, 4, 5. Okay, let me make it take it upper a bit, upper a bit. So now you have your H, then you have C, double bond O. So another carbon here, another one here, making 3, 4, 5, then you have 6. Are you getting it? Now starting from here, this is your first carbon, HOH. You draw another one again, HOH. So you change it again. You will have HOH. So again you have HOH. Again you have OH. OH. So here finally you have CH2OH. So this structure I drew here, so let me clean it up so that it can look very, I understand what I'm saying. Now look here. So this structure I just drew here is the closed chain structure. Closed chain structure of glucose. So this is the closed chain structure of glucose. Now I want to draw the cyclic chain structure of glucose. Now to do that, I want you to take note of something. There's something we have the pyrran ring and the furan ring. So glucose happens to have the structure of the structure on the pyrran ring. Are you getting it? It happens to have the structure on the pyrran ring. It can be represented on the pyrran ring. Now look at it. This is a pyrran ring. So this is a pyrran ring. So 1, 2, 3, 4, 5. Oh, it has 6 edges. There's a mistake here. It has 6 edges. 3, 4. So 1, 2, 3. Can you see this is a pyrran ring? It has 6 edges. 1, 2, 3, 4, 5, 6. So pyrran ring. This is a pyrran ring. Why this is a furan? Furan is the one having 5. So let's be full. I don't want to deviate. I can release that in another video. So now when you do this, now number this as carbon 1, this as carbon 2, carbon 3. Here you have 4, here you have 5, and here you have 6. Are you following? Now let's go. So the first thing that happens, now there will be a change at the, something will happen, there will be a reaction. Imagine there's a reaction at the carbon 1 and carbon 5. Now I will show you some things now. What I will show you is this. Now this O, imagine this O will form an alcohol. So imagine this O reacting with this H here. I get what I'm saying. You will still get it fully. So this O, imagine it reacting with this H here. So when it happens, what happens? The first thing. Now let's start. When you are numbering your glucose, on the ring, this is your number. This is your carbon 1. You assume that there's a carbon at each edge. This is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Then finally we have your carbon 6 here. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Okay, you have 5 carbons here. So 1, 2, 3, 4, 5. Are you getting it? Now let's go. Let's draw the cyclic structure. Now the first thing that happens, this H will come. Then you have, so this O now, I said something the other time that imagine a reaction taking place between this double bond O and this H here. Then an alcohol is formed. So the alcohol that will be formed from that reaction will be put here. You have your OH here. Okay, let me write it in a clearer way. You have your OH here. Are you getting it? Now it follows. Now go to your carbon 2. You have H here. You have OH here. No need for a reaction. So now H, OH. Now back to the carbon 3. Now what happens at the carbon 3? So you have HO, H. Write it straight away the way it is. HO. Okay. The hydrogen is bonded to the carbon is bonded to the oxygen here. So HO, you have your HO, write as OH. Then H. Then back here, we're on the fourth carbon here. Then we have H. Are you getting it? We have H here, then followed by OH. This is it now, HOH. Now, finally, the fifth carbon. This is the fifth carbon here. I told you something the other time that see this O has reacted with this H. Are you getting it? This O has reacted with this H. So this H has gone. This H has gone already because it is the one here combining with the O. Gone already. So when it has gone, what are we left with? We are left with the alcohol. Do you know what happens now? This alcohol will react to become an ether. So when it becomes an ether, it will break up to oxygen and hydrogen here. Then that's the reason for the O you have been seeing in glucose. So when it happens here, so the next thing that will happen, this is our carbon 5. This is already our carbon 5 here. Let's note it. This is our carbon 5 here. So the carbon is here. Now what happens to the carbon 5? The next thing that happens is that we have where this CH2OH we hang here, CH2OH, and what follows, and this H that remains after the breakdown of alcohol into oxygen and hydrogen, the O comes here and the H comes here. So what you have finally is the structure of glucose. So what you have is the structure of glucose thereafter. So this is the structure of glucose. Now let me quickly show some things. We have the alpha and the beta glucose. Now this structure here is the structure of the alpha glucose. Now, why do I say so? On the first carbon, you determine which one is the alpha or which one is the beta glucose. Now, this is what happened. Look at something here. So this is an alpha. This is an alpha glucose. Yes. So the reason why it is an alpha glucose is because the hydroxy group is down. Are you getting it? That's why it is an alpha. So when you're talking of a beta glucose, the hydroxy group will go up. So let me draw a beta glucose for you to get what I'm seeing better. So here also, I'm sorry. So you have it here. So this is beta. So draw it. I'm sorry for my structure. Now, this will be so OH H. So the same thing remains. The rest as it is H OH HO H H OH. Are you getting it? Then you have your HCH2OH. Can you see? So this is an alpha glucose. This is a beta glucose. Are you getting it? So this is an alpha glucose. This is a beta glucose. So you can also write like this: beta glucose. So this is alpha glucose. So that's that. Now, I think by now you should be able to draw the structure of your glucose, and you know how it is come about. So it's just like rotating. So if you look at it carefully, another way, that's HOH, HOH. So HOH twice, then OHH, HOH again, then CH2OH, H. And you see that's what is happening. So just notice that trend. Now, this is the alpha glucose, this is the beta glucose. Okay, now let's talk about the formation of maltose. Are you getting it? No, maltose result from the reaction between two alpha glucoses. Are you getting it? So when two alpha glucoses come together, what you have is maltose. Now, how does it occur? Now, maltose gives us something we call the alpha 1,4-glycosidic linkage. The alpha 1,4-glycosidic linkage. So why are we saying alpha 1,4-glycosidic linkage? I will show you in this video now. Please be attentive to it. Now let's go. So I told you that maltose is as a result of reaction between two alpha glucoses. Now, what will happen? This is what happens. This one. Let me do another alpha glucose here. Okay. Now this is it. Please manage my structure. This is the 6. This is the pyran ring. So now let's go. We have our, let me redraw it, I'm sorry. So this is it. What you have here, you have your 0 here, you have your O here. So the same way it comes also. So let's go. Yes. So let's go. I'm sorry, manage the structure as it is. So this H, the same way, H O H, H O H, then you have O H, H, then you have H O H again. Are you getting it? Then here you have CH 2OH, then you have H. Now, in some structures, you might not be seeing hydrogen there. It doesn't mean it's not a glucose. It's still a glucose, but they decided not to put the hydrogen. It's not compulsory. It's only the hydroxy part that is compulsory you indicate. Are you getting? So you might not see hydrogen in some structures, but it's still glucose. Now let's go. So now the reaction between them, 2 alpha glucose. This is an alpha glucose. This is an alpha glucose. Alpha glucose. So when they react together, do you know what happens? So this, I told you when counting your glucose, you start from carbon 1, carbon 2, carbon 3, carbon 4. Are you getting it? So the same way, this is your carbon 1, carbon 2, carbon 3, carbon 4. Now, the carbon 1 of this glucose, the hydroxy there will join with the hydroxy of the carbon 4 of this glucose here. Now, when they join, do you know what happens? Now look at what happens here. This is where the reaction takes place. Now this is where the glycosidic bond is formed. So now alpha glucose, the hydroxyl of it and the other they react. So when they react, you know what will happen? Water will be removed from it, and when water is removed, so they will merge together. So then the resulting thing we have is maltose. Now what will happen? When water is out of it, you know, oxygen will be left. Are you getting it? So now this is how the linkage will look like. I hope you are following. So what you now have now is they will now be bonded together by the oxygen. Are you getting it? Now they bonded together by the oxygen. So the resulting structure you have now will now be maltose. Are you getting it? It will be maltose. And the bond there is alpha 1 for glycosidic linkage. What's the meaning of the alpha 1 for? That is alpha glucose. Are you getting it? Alpha glucose. Alpha 1. That means on the first carbon. It's bonding on the first carbon. Then 4. The other 4 means it's bonding with another glucose on the 4th carbon. Are you getting it? Alpha 1, 1 for glycosidic linkage. Can you get it? So that's it. So what the other one you have is maltose. So this is the structure of maltose. If anyone wants to draw the structure of maltose, this is how it looks like. So thank you for watching my video. Please subscribe. And if there's anything you want me to make video on, please tell me in the comment section. Thank you.